Welcome back in today's session. I am Professor Fayaz Kawadi from Department of Mechanical Engineering. In this session, we are solving some numericals on epicyclic gear train from Unit 3 Gear Train from Theory of Machine subject. The problem statement is in front of you. In a reverted epicyclic gear train, the arm A carries two gears B and C and a compound gear DE. The gear B meshes with gear E and the gear C meshes with gear D. The number of teeth on gear B, C and D are 75, 30 and 90 respectively. Find the speed and direction of gear C when gear B is fixed and the arm A makes 100 revolutions per minute clockwise. Before start solving the numerical, first of all, we have to clearly understand that what is a reverted epicyclic gear train. As discussed in previous session, the reverted epicyclic gear train is in front of you, in which when the axis of first gear, this is first gear, the axis of first gear and the axis of last gear, that is fourth gear. One gear is meshed with second gear and 2 and 3 is mounted on same axis, same shaft. Okay, so and gear 3 meshed with gear 4. So when the axis of first gear and the axis of last gear are coaxial, see here in top view we can see that the axis of first gear and the axis of second gear is collinear, but both the gears are mounted on different shaft. You can see here shafts is cut here. So speed of 1 is not equal to speed of 4, but this 2 and 3 is mounted on same shaft, on single shaft. The speed of 2 is equal to speed of 3, but here speed of 1 is not equal to speed of 4 because gear 1 is mounted on another shaft and gear 4 is mounted on another shaft, but the axis of both the shaft you can see collinear. In front view you can see the same axis of gear 1 and 4, but these are different, and that you can see in top view. So this is the special feature of a reverted epicyclic gear train. That's why it is called as a reverted, when axis of first gear and axis of last gear is coaxial but mounted on different shaft, that is called as a reverted gear train. The same thing we are using here also in this figure also. The axis of B and the axis of C is coaxial, but both the gears is mounted on different shaft. So speed of B is not the same as speed of C, but speed of D and E is same. Why? Because it is mounted on same single axis, single shaft. Okay, now come to the solution. Number of teeth on B and C and D is given 75, 30 and 90 respectively in the problem statement. Speed of A is given 100 rpm clockwise, and our assumption is clockwise direction we are taking as minus, and anti-clockwise direction rotation we are taking as plus. So NA is equal to, while solving the numericals, we are taking NA is equal to minus 100 rpm. Okay, the reverted epicyclic gear train is shown in that figure. First of all, let us find the number of teeth on gear E, because TE is not given. Here TE is not given. TC, TB and TD is given, but TE is not given, and that will be required for solving the numerical. So first of all, we will find out the number of teeth on gear E, that is TE. Okay, now DB, DC and DD and DE be the pitch circle diameter of gear B, C, D and E respectively. Okay, so from the geometry, I can write the statement. From the geometry, I can write the statement dB plus dE is equal to dC plus dd. How? From this, as discussed earlier, the distance between the center of shaft of gear 1 and 2 as well as 3 and 4 is same. The center distance for gear 1 and 2 as per previous figure, and center distance for 3 and 4 is same. So I can write down the statement R1 plus R2 is equal to R3 plus R4. So the same statement is written here also. dB plus dE. dB mesh with dE. So a radius of B, RB plus RE is equal to RD plus RC. RC plus RD. Okay. So instead of writing in terms of pitch circle radius, the formula is written in terms of pitch circle diameter. dB plus dE or RB plus RE. RB plus RE is equal to RD plus RC. RD plus RC. Okay. So from this statement, from this equation, since the number of teeth on each gear for same module are proportional to the pitch circle diameter. You can see here pitch circle radius, as you know the formula for module is equal to d by t, but in terms of, instead of writing in terms of d, I am writing here formula in terms of radius. Pitch circle radius is equal to r is equal to m t1 by 2, r2 is equal to m t2 by 2, same as r3 m t3 by 2 and r4 m t4 by 2. So from this equation, the same value I am putting here, mt1 by 2 plus mt2 by 2 is equal to mt3 by 2 plus mt4 by 2. As module is same, as the gear teeth are meshing with each other, so module is same. So this will get cancelled. M by 2 is common. T1 plus T2 is equal to T3 plus T4. R1 plus R2 is equal to R3 plus R4. So the same formula is converted like as T1 plus T2 is equal to T3 plus T4. Now come to our problem. So from this problem, this statement, I am getting the new statement here in terms of teeth. TB plus TE is equal to TC plus TD. Okay, so we have to find out about teeth on gear E. TB value is given, TC is given and TD is given. So TE is equal to TC, which is 30, plus TD, which is 90, minus TB. TB will move right side, so you are getting here minus 75. Minus 75 TB is given. So number of teeth we are getting here on gear E is 45. So TE we are getting 45 number of teeth. Now come to the problem solution. I am writing here the table in which in vertical column I am writing condition of motion, and in horizontal I am writing all the elements of gear train. The different elements here are arm A, compound gear D and E, gear B and gear C. Okay. Now first condition, fix the arm and give one revolution in anti-clockwise direction to compound gear DE. Fix the arm and give one revolution in anti-clockwise direction to compound gear DE. You can give one revolution to gear B and C also. You can solve by a different step also. So I am giving one revolution to compound gear DE in anti-clockwise direction. When I am giving one revolution, so here I am writing +1. Now we have to find out the speed of gear B. I am getting speed of gear B is minus TE upon TB. How? TE upon TB. See here. I have standard formula for speed ratio is NE upon NB. NE upon NB. NE mesh with B. So speed of driver divided by speed of driven. NE upon NB is equal to, as these two are formed external pair. So if this will rotate in anti-clockwise direction, which will rotate in clockwise direction, and sign of B will be minus. So NE upon NB is equal to minus TB upon TE. I am taking the reciprocal of that, NB upon NE. Why? Because I have to find out speed of B. Okay. So NB upon NE is equal to TE upon TB, and but minus sign. So NB is equal to minus T upon TB into NE will move right side, NE. So NB is equal to minus T upon TB into, what is the speed of E? I am giving one revolution to compound gear in clockwise direction. So NE will +1, as we have already written in that table. So NB is equal to minus T upon TB. Minus T upon TB. If you make mistake in writing the speed of NB, it will directly reflect here and your answer will be wrong. So while writing here, take precaution. Now we have to find out speed of C, gear C. Again, speed of gear C, you can see we have to find out speed of gear C, and C mesh with gear D. Okay, so standard formula ND, speed of driver, divided by speed of driven. We have to find out NC. That's why ND upon NC is equal to, again this form external pair, so minus sign, minus TC upon TD. Again taking reciprocal, NC upon ND is equal to minus TD upon TC. TD upon TC. So NC is equal to minus TD upon TC into ND. ND will be right side. Okay. Minus NC is equal to minus TD upon TC. But what is the value of ND? Again, D and E is compound gear. So whatever the speed of E, the same speed the gear D also. So ND is equal to +1. ND and NE is compound gear. So speed of NE and speed of ND will be same. So value of NE is equal to value of ND. So ND is equal to +1. So NC is equal to minus TD divided by TC. So same value is putting in that table, minus TD upon TC. Now the second step, fix the arm, give X revolution to all the elements. So 0 plus X multiply by X to this term minus X T by TB, and multiply X to this term minus X TD by TC. Third step, add Y revolution to all the elements. So plus Y, plus Y, plus Y, plus Y. So total motion for gear A is addition of 2 and 3, 0 plus Y plus Y. Here speed of compound gear is X plus Y, addition of 2 these above 2 and above 3. Speed of gear B is equal to Y minus X into T by TB, and speed of gear C is equal to Y minus X TD by TC. So you have to write properly these term and these term. Why? Because this will directly affect your final answer. If these two terms, if you are calculated wrong, this term will be wrong and this term will be wrong. So your final answer will be wrong. Okay. After writing all the values of arm A, compound gear D and B, gear B and C. After getting this formula, we are solving the numericals, finding the speed. Gear B is fixed. Gear B is fixed. See here, find the speed and direction of gear C. We have to find out NC. When gear B is fixed and arm makes 100 revolution, arm makes 100 revolutions, so y is equal to 100, but clockwise. So clockwise direction will be minus 100. Okay, I'm written here y is equal to minus 100 because clockwise direction is given in problem statement, and our assumption is clockwise rotation is given minus sign. So y is equal to minus 100 and x plus y. Okay, and so gear B is fixed. Gear B is fixed. So y minus x, t upon tb is equal to 0. Gear B is fixed in the problem statement that is given. Gear B is fixed and arm makes 100 revolution clockwise. So this will become 0 and this will become minus 100. So, and we have to find out the speed of gear C. Here, find the speed and direction of gear C. So, speed of C is equal to y minus x, td by tc is how much? So, y is equal to minus 100. So, minus 100 into 0.6x. Y minus y is 100 minus x, we have to find out x into number of teeth given 45 and 75. 45 we have already found out. So this term is 0 because gear B is given stationary fixed. Gear B is fixed. Gear B is fixed. So this whole term will become 0, but value of y is minus 100 and x we have to find out into 45 and 75. So this equation will become y minus 0.6 x is equal to 0. Y minus 0.6 x is equal to 0. So value of x we are getting here minus 166.67. So putting the values of x in this equation, because we have to find out speed of gear C. So y minus x td by tc, and c is equal to y minus x td by tc. So putting the values of y, putting the values of x and td by tc, we are getting, by solving this equation, we are getting speed of c is equal to 400 rpm. As sign is plus, so the gear C is rotating with 400 rpm in counterclockwise direction. Come to the second numerical. An epicyclic gear train consists of 3 gears A and B, A, B and C as shown in figure. The gear A has 72 internal teeth and gear C has 32 external. The gear B meshes with both A and C. Gear B meshes with gear A and C and is carried on an arm EF which rotate about center A at 18 rpm. If the gear A is fixed, determine the speed of gear B and C. So as per the problem statement, we are making that table. Condition: arm is fixed. Arm is fixed. First of arm is fixed. Gear give 1 plus a revolution to gear C. So gear C is making 1 revolution. So what is the speed of gear B? Gear B. So speed of gear B we have to find out. NC is here driver. Why? Because we are giving 1 revolution to gear C. So NC by NB is equal to TB by TC, and both form external pair, so sign will be minus. So I am taking a reciprocal of that. NB upon NC is equal to minus TC upon TB. So NB is equal to TC minus TC by TB into NC, but NC is equal to 1. So NB is equal to minus TC upon TB. Minus TC upon TB. Now we have to find out speed of gear A. Speed of gear A. Now see that figure. We have to find out speed of A. Okay. So NB mesh with B mesh with A. So NB become driver and NA become driven. So NB by NA is equal to TA by TB. Okay, so taking reciprocal of that, NA by NB is equal to TB by TA. So NB will become, and both the form internal pair. So what is the direction of B is same the direction of A also. So B will rotate in anti-clockwise direction. So A will again rotate in anti-clockwise direction. So plus sign. Okay, NA is equal to TB by TA into NB. So NA is equal to TB by TA into what is the speed of NB? We have already found out here, minus TC by TA. Putting the values of here, minus TC by TB, TB will get cancelled. NA is equal to minus TC by TA. Minus TC by TA. So same value I put here, minus TC by TA. Now second step is arm fixed, gear C rotate through plus X revolution. So multiply all this term to X. So it will become 0 plus X minus X into TC by TB minus X into TA TC by TA. Third step, add Y revolution to all the elements. So plus 1 plus Y plus Y plus Y plus Y. So total motion will be addition of above 2 and above 3. So 0 plus Y is equal to plus Y. Here X plus Y. Here Y minus X TC by TB, and addition of these two will be Y minus X TC by TA. So this is the speed of gear A. This is speed of gear B. This is speed of gear C, and this is speed of arm EF. Okay. Now we have to find out speed of gear C. Speed of gear C. X plus Y. X plus Y. We know that the speed of arm is 18 RPM. Speed of arm. This is arm 18 RPM. So Y is equal to 18. 18. Gear A is fixed. Gear A is fixed. This is given in problem statement. If gear A is fixed, determine the speed of B and C. So gear A is fixed. That means this is gear A. So this whole term will become 0. Y minus X TC by TA. This whole term will become 0. So putting the values of Y here, 18 minus X TC 32 divided by TA 72. That is given in problem statement. So value of X we are getting here 40.5. After solving this equation, the value of X is getting 40.5. So speed of gear C is X plus Y. So X plus Y is equal to value of X is 40.5 plus value of Y is given here 18. So addition of these 40 plus 5 plus 18 is we are getting here 58.5 RPM. In the answer is by plus sign, so it is in the direction of arm, as that of arm is plus sign, so gear C will rotate again in anti-clockwise direction. Plus sign is. Now we have to find out speed of gear B. speed of gear B. So speed of gear B is equal to y minus x Tc by T. That we have to find out. Y minus x Tc by T. So dA, dB and dC, these are the circle diameter of A, B and C respectively. So from this figure, I can write down 2 dB plus dC is equal to dA. How? This is diameter of C, this is diameter of B. So diameter of B plus 2 times diameter of B here, and the same diameter will be here. So this total diameter of A, dA is equal to dC plus 2 dB and here also dB. So 2 dB will become here 2 dB plus dC is equal to dA. Correct? So the same statement is written here, 2 dB plus dC is equal to dA, bigger diameter. So from this D term, I am writing here 2 TB plus TC is equal to TA. 2 TB plus TC is equal to TA. So putting the values of TC and TA here, I am getting the value of number of teeth on gear B is 20 by solving this statement equation. Okay, TB is equal to 20. So putting the values of TB here 20, 18 is the value of Y and X is the value of 40.5 is the value of X. TC is given 32 divided by 20. So speed of B I am getting here 46.8 RPM. In the opposite direction of R. So at the end of the session, student can solve the different numericals on epicyclic gear train.